This is a demonstration of atmospheric pressure. What we have are a lot of tiny little red little balls, and they've got a little bit of weight inside of them, but each of these is going to represent one air particle, and they've got springs in between them to help them space out. Right now, they're all evenly spaced, but what we're going to see is that when we turn it vertically, they start to compress. This is the same thing that happens in our atmosphere with the air molecules. Because when the air molecules are all stacked on top of each other, the more air that is on top of a molecule, the more compressed it gets. And this is where we get our atmospheric pressures from. If we're down here at Earth, then the air molecules are really squished together. We've got one atmosphere of pressure on top of us, and then we experience that air pushing down on us. It's the kind of thing that we don't notice because we're so used to that air pressure. But once you start going up higher in the atmosphere, and there's less air on top of you, less air pushing down, you have it spread out more. It's a lower pressure. This causes all sorts of things. Like, for example, if you've ever flown in an airplane, you know when your ears pop as you're taking off? That's because as you go up, the air pressure outside of you is pushing in less. The air pressure inside of you is bigger, so your ears pop to help equalize that pressure so that nothing happens. It keeps it balanced. But up in the atmosphere, there are less air molecules pushing down, and so the atmospheric pressure is much lower. With this demonstration, we could even flip it over and do it the other way, and you'll see no matter what, it just depends on how many air molecules are pushing down. The higher the pressure, the more air is pushing down, the more pressure you get.